bicycles. The invention of the bicycle was the biggest advance in personal transportation since the domestication of the horse. Bicycles are still one of the most energy-efficient forms of transportation. There are more than 1 billion bicycles in the world, with up to 100 million added every year. Transmitting power. A bicycle rider's muscle power is transmitted to the back wheel by a chain connected, via levers called cranks, to the pedals. The rider can pedal efficiently only within a narrow speed range. Gears enable the rider to stay within this range by turning the back wheel faster or slower for the same pedaling rate. Bicycles are made up of different components. There's the frame that consists of two triangles, forming a rigid structure. The wheel, to allow for motion. The pedal to apply force to the crank. The crank acts as lever to turn the chainring and move the chain. The gears. Some bicycles have high and low gears. High gears are small, turn faster, and increase speed. In a high gear, each rotation of the pedals turns the wheels further than in a low gear, increasing the speed of the bicycle. Low gears, on the other hand, produce more power at the cost of speed. When using a low gear, the rider turns the pedals many times for only one rotation of the wheels. Each gear has a different number of teeth, allowing the rider to choose a range of gear rations to suit the incline being tackled. The derailleur changes gear by shifting the chain from one sprocket to another. Handlebars. Handlebars are levers that magnify the input force to turn the front wheel. The handlebars turn the headset, which turns the front wheel. Some bicycles have drop handlebars. These make the rider bend lower, into a more aerodynamic position. Brakes. Caliper brakes consist of pads on either side of each wheel. Squeezing the brake lever pulls a cable that makes the pads grip the wheel, increasing friction and slowing the wheel. Freewheeling. Two mechanical principles usually help to explain why a bicycle can stay upright: the gyroscopic effect and the caster effect. The gyroscopic effect. The front wheel acts like a gyroscope. If the bicycle falls to one side, the gyroscopic effect turns the wheel to the same side, keeping the bicycle upright. The caster effect. The point at which the front wheel meets the ground trails behind the steering axis, like a caster on a trolley. This means that the wheel always turns in the same direction as the bicycle is traveling. Recent research suggests another important influence is the fact that the front of the bicycle has a center of gravity that is lower than the rear and forward of the steering axis. During a fall, the front of the bicycle falls faster than the rear, turning the front wheel toward the fall and keeping the bicycle upright. Maintaining balance. To balance on a bicycle, a rider must control his or her center of gravity. When cycling in a straight line, the rider steers toward a fall to make sure that the center of gravity is always over the wheels, forming the base of support. And there you have it. We hope you learned something new today. If you enjoyed the video, please like, comment, subscribe and share with someone that you know. Thank you for watching. We'll see you in the next video.